Howdy folks, welcome back to another CS128 honors lesson. Today we're going to be moving on from our discussion of ownership, though ownership will continue to come up in almost all of what we do, and we'll be beginning our discussion on structs. To be honest, our discussion on structs will actually be pretty short, so our goals for today are first to review ownership and borrowing and things like this. Then we'll take a quick aside into modules and the pub and paths, pub keyword and paths in Rust, which you've been exposed to a little bit as well, but are going to be pretty important when it comes to future projects and understanding what you're reading. And then also we'll introduce structs, which will be pretty short. They're basically just tuples, and we'll introduce some fun syntactical shortcuts for structs. Additionally, we'll give some quick discussion on a common use case of structs where you want to have a struct with a reference to a thing and how that can create some problems and why you might want to avoid it. But in either case, today's lesson is going to be pretty useful for your final projects. So without further ado, we'll go ahead and get started. Some quick reminders. Homework 4 is due tonight, February 17th at 11:59 p.m. MP1 is due February 23rd, so next week at 11:59 p.m. We hope that y'all like MP1. We think it's pretty cool. Let us know any feedback that you have, of course, in the feedback forms at the end. Those are pretty useful, and we'll look at some of the previous ones in just a moment here. But, try to get started on MP1 a little bit earlier. It is slightly longer than MP0, but also you're a lot better. So we suspect it maybe we'll take less time, maybe we'll take more. We'll see. Some quick updates. It is currently a blizzard outside, and so this is what the quad looks like right now. I hope that you are all staying safe and staying warm. I think it is getting down to -2 tonight. So, okay, definitely stay warm and definitely stay safe. Yeah, look at that. With 25-mile-an-hour winds right now. Okay, so obviously you can see no one's on the quad because no one wants to freeze to death. But first, before we get started, let's discuss some comments. Of course, the Rust crab emoji Rust will always be put on lecture. That's always fun. Is there another way to clear a string, a mutable string reference, beside using the clear keyword? So, okay, the answer is yes. This question is effectively the exact same as, is there any other way to clear a string that you own? And the answer is yes, but I think clear is the cleanest way. There's string functions like retain, which, iterates over all of the characters in the string, and if it matches some predicate, like, let's say x is not equal to comma. So this removes all of the commas from a string, because you're retaining all of the characters where this is true, right? Which, of course, it's false on comma. You could replace this with false, just a statement that always returns false, and then you'll retain none of the characters, and you've cleared it in a way. You can do, other ways. You can actually get the raw bytes of a string, and you can adjust those directly. You can change the capacity and the length of a string directly. And, these are all sort of theoretically possible, but move into the realm of unsafe Rust. Maybe just stick to clear, but yes, there's plenty of ways. Wondering if PrairieLearn could also tell us why our code doesn't compile. So the short answer for this is yes, we can. However, we really, really, really want to prefer you to work locally or on your VM, just because it's really going to be absolutely necessary when it comes to your final projects. My hair is stuck in my headphones right now. Okay, there we go. It's really going to be absolutely necessary when it comes to your final projects, and so getting y'all to work as much as possible in your machine, we think is a good thing. If there is a really strong reason why y'all think, being able to compile on PrairieLearn is better, let us know. But just for example, on this MP1, for example, if you don't download it locally, you won't see, things like our main.rs, which builds this dataset struct. You won't see the actual data itself. We have the CSV in that, in case that might help with, debugging or exploration or just interest. And, absolutely worst case, you have these files and you don't use them until final project time when you're like, okay, hey, a similar thing happened in this MP. Let's see how they did it. And then you can just reference our code. So, short answer, yes. Long answer, if there's a strong reason to do it, we will. If not, we won't. Let's have some quick review of ownership. So there's three major rules. Each value in Rust has a variable called its owner. There can only be one owner, and when the owner goes out of scope, the value is dropped. Similarly with borrowing, we use the and% to represent a reference. A reference allows us to take some value or to refer to some value without taking ownership of it. And we call this action borrowing. When it comes to borrowing things or taking references, you can either have one mutable reference or infinite immutable references. Hopefully this should make sense. We have some piece of data here. We can either have an infinite number of people who are read-only, or else, let's say there's one person who's who has read-write. There's certain situations that can occur that, cause race conditions. So if agent A and agent B attempt to perform some operation at the same time, A reads, B writes, then what happens is, let's say B wants to change this to 6, A wants to read the 5. Whoever gets there first wins. So A might read a 5 if A gets there first, and A might read a 6 if B gets there first. How do we know who gets there first? Well, in the case that A and B are multiple threads, it's up to your operating system. It schedules these different processes to be sent to the CPU, and so it's completely at your operating system's whim, and your program is no longer deterministic because it depends on a million other things. What other programs are running on your computer, for example? Okay. And we'll see actually this kind of behavior of multiple threads messing with things at the same time. There's other issues as well, like, if with ownership and things being dropped, but we won't get too deeply into that. And of course you can't have two things writing at the same time, right? Same issue. Okay, and let's actually go to the side a little bit now and discuss some about modules in pub and paths. So pub is a keyword, modules are a way to organize our code, and paths are how we access that code that we've organized. At its heart, modules allow us to organize our code and to control the privacy of that code. So this is from the Rust textbook. We have some example, we have the front of house module, the hosting module, the serving module, and just a quick reminder, these module keywords that I'm using, I know this is new, this is only a tool. Think of it as just a folder, right? It isn't functional really in a lot of ways. It's just a way for us to organize our code. Anyway, when we, look at the tree of this, this is what we have. So at the heart of everything is the crate package. And then we have front of house, which is here. We have hosting, serving. These each have their own functions within. These don't have to be functions. This could be a struct, an enum, many things, almost anything, right? Anything that you can put in a file, really. Okay, and so, we'll look at an example a little bit closer to our case. I just realized I forgot an H there. Whoops. So let's say we have some CS128 honors module that has PrairieLearn in MP, that has the PrairieLearn module within it, that has homework in MP, and each one has grade and submit for its respective things. This is what that looks like as a tree. Remember, technically at the base of it all is the crate package. And let me get this real quick. Okay, one moment. Seems to be a technical issue on my side. Patience, please. And we're back. Whoops. Okay, now we're actually back. Wonderful. Sorry about that, folks. So we have our modules here, and this is just a way to organize our different functions. And let's say, for example, our main function is right here. Okay, so we can say our main function is here, and we can literally explicitly sort of type these out. This is one way of defining modules, albeit this is maybe not a great way to organize it if these are very long. How can we go and access these? Well, by default, modules are private. So this function is private. If we want to make it public, we can use the pub keyword to make them public. Okay, the tree remains the same. It's just what we have access to. So this main function, well, here, let's give this one example at a time. So if we are at here, if we're at submit MP, we have access to grade MP, and grade MP has access to submit MP because these are defined in the same module. Okay, these things do not necessarily have access to submit homework, but they do have access to things like grade homework and homework because homework is public. Okay, so in our main function, this is defined at the same scope of CS128. So we can think of it like this, sort of main, right? So we do have access to the CS128 module, even though it's not listed as public, because these are defined in the same place. Do we have access to the PrairieLearn module? Yes. It's listed as public, we're good to go. Do we have access to the homework module? Yes. Listed as public, good to go. Grade homework? Yes. We do not, however, have access to submit homework because this is not listed as public. Even though homework is, and we have access to that, we don't have access to submit homework. Okay, what about grade MP? Grade MP is listed as public, but the module that it is inside is not. And so we do not have access to grade MP. Okay, and that's pretty much it. When it comes to actually accessing these things, if we're in our main function, we could do something like CS128 honors colon, and then this is how we sort of define paths in Rust. We'll say PrairieLearn. Okay, I'm going to shorten PrairieLearn because it's very long to write with a mouse. Homework, grade, homework. And now we have access to this directly. Of course, if we tried to say submit homework here, we'd receive an error saying we don't have access to this. Wonderful. So does anything change when we move into this layer here? So instead of being, here, we're now on the same level as PrairieLearn. Effectively not, right? Effectively, this is the same. The only difference is we no longer have to say CS128 honors PrairieLearn homework grade. Homework. So we no longer need the CS128 honors because we're already in that module. Or the colon. Wonderful. We can use the use keyword to make paths shorter. So right now we have CS128 honors PrairieLearn homework grade homework. And we can say use CS128 honors PrairieLearn homework because maybe we have to do this a lot and we don't want to type out 50 characters every time. Now we can just say homework grade homework. So that makes our lives a little bit easier, which is nice, or sometimes a lot of it easier. And so let's also analyze how we can actually create these modules in our projects. First, the mod keyword. Just like before, we have our main function here. This is in the main.rs file. We define some mod. We can have structs in here. We can have functions in here. Remember, we won't have access to the struct because it's not public. We will have access to this function here, though. And, of course, the module itself, because these are in the same spot. You can also put it in a file with the module's name. So these represent two different files. This one, main.rs, which is what you normally code in. Okay, technically, I think you're coding in lib.rs, but similar. Effectively the same. Main.rs is run when you do cargo run. Okay, and we have some main function here. We can say mod CS128 honors, and this is going to go search for some CS128 honors.rs file. And in that file, we can have the same stuff. And so this is effectively the exact same, but this just allows us to separate this into another file for increased sort of organization. Okay, but this can actually even go a step further. So what if, this is a huge thing, and even this CS128 honors module has submodules, and it's crazy large, and it gets a little funky. We can put it in a folder. So when we do this mod CS128 honors, it first looks for the file, and then, whoops, I forgot to change this. Then it will look into, I wonder if it's in the next screenshot. Okay, it's not. Okay, and then it will look into the CS128 honors folder, and then the mod.rs file. And this mod.rs file can have its own mods to control, privacy. It can have other folders within the CS128 honors folder with their own mods. And so this can sort of recursively cover infinite complexity of privacy and hierarchy and whatever. I mean, okay, up to the whatever depth your operating system lets you create folders, which I think isn't infinite. But I don't know what it is. Maybe it is infinite. I don't know. I think it's some power of 2. Okay, so these are the different options. Apologies for the errors on this last one. And so that's it. So let's now sort of discuss structs. So again, brief sort of last note on these modules. I recommend that you use modules in your final projects because it is a way to organize your code so that it is not ugly. And we do care about reading clean code when it comes to these final projects. Some of our best projects from last semester are the ones that are written the most beautifully, right? So let's discuss structs now. We've been exposed to structs a couple of times. They're very similar to tuples. They do allow for some more flexibility. At their heart, structs are very similar to any other data structure like a tuple that you've seen. But we are going to explore how they can act more like what you've known as classes for a while in other languages. And they'll have associated functions. You've heard us briefly discuss this word called a trait. They have traits that you can associate with them, and that really just ties functions into them as well. And that's pretty much it. So how do we create a struct? Well, the first step is using the struct keyword. Hopefully that isn't too surprising. We can name our struct whatever we want. We do want to try to stick to this capital letter casing because that's sort of semantically correct. I think it's also fine if this first letter is lowercase. I think that's camel case versus capital case or something. Inside of a struct, we have what we call fields. Fields are an associated variable name and a data type for that variable name. So we can look at a concrete example. We have our student struct, and we have a field called name that is a string, a field called netID that is a string. And that's it. So what are the limits on what we can put inside of these fields? Well, pretty much anything. If you can define some variable to be it, we can have like let name, which is a string, equal something. We're basically just taking this part and putting it here. So anything that you can sort of create a variable like that for, you can add to a struct. So in this example, we have a vector of students, right? And so this student struct is something that we just created. We can add this to a vector. Of course, this is dynamic size, it's on the heap, etc., right? All sorts of fun stuff happening. So yeah, these structs can get pretty complex in the data types that they hold. You'll see in MP1 or MP2, MP1, I think MP1, yeah, k-nearest neighbors, that we have the dataset struct, which has a vec of float 64, I want to say. Maybe it's 32, who knows. And this represents, we have our data set here. Each row is a sample in our data set. So that's this first level of vec. The second level of vec is, okay, each row also has many features, right? This is fat. This is carbs. Calories, etc. There's many. I think there's like 10 or 12 or something. Okay, and each of these have some variable associated with them, which is nice. Okay, we can instantiate our struct like so. So we've defined our struct somewhere, or maybe imported it from a module. Then we can say, just like any other variable, we can type our variable if we want. Let my student, which is a student, equals student, and use these curly braces to actually define the values for the different fields in my student. So name is going to be a string, William Eustis. Net ID is going to be a string, Eustis2. We can also define our structs to be mutable. So we can say, hey, I want to be able to change these values. And so we can change it to Neil and Neil K3. And that's pretty much it. I mean, this is like, at this point, the vast majority of the discussion on structs. They can hold data. Okay, not the vast majority. We haven't talked about functions yet, which you'll talk about next lesson. But in terms of how structs interact with data stored in them, this is the majority. So we can update them, and we can, pass things in. It's very useful to often build functions to simplify things. So build student. Potentially this student class has some defaults. Okay, everyone enters the university with a GPA of 4.0, with 0 credit hours. I'll just say CR of 0. We don't want to have to pass these things in every time. And in fact, net IDs are also generated based on the name. So maybe we have some function that converts the two, and we only have to pass a name, and we get this nice student struct out of it. So this can be very useful for a lot of your final projects. This can be simplified a little bit. So if the variable name and the field name are the same, then we only have to specify the field name or the variable name. I mean, it's the same, so you can call it whichever one you want. And that's pretty much it. We can have a function return a student. You can have students as parameters to a function. Infinite flexibility. But I do want to analyze a little bit on what happens with ownership in this case. Just because I think it's sort of interesting, and it brings up this idea of what happens if a struct has a string reference, which we'll get to in a sec. So we have our two strings. We want to have name be mutable because we eventually want to try changing it. We will construct our student struct. This will call this build student function, which will return a student with that name and that ID. We'll store that into student A, and then we'll attempt to edit this name string. Okay, so take a moment and ponder what error you're going to get, or if this will work. So if we were to try to print, we'll say right here, student A dot name. Will we get William Eustis? Or will we get William Eustis is cool? Okay, well, I sort of will prove this by a caveat, which is, let's say for a moment that this is inside another level of scope, or anything, and name goes out of scope. But student A does not. Maybe we return this to some other function. Well, if this was true, we needed ownership on line 18 to adjust this, to edit this string. And if name goes out of scope, then this will be dropped. And then we would have a struct that is pointing to an invalid location in memory because that string has already been dropped. So, we sort of come into a fallacy there, or a conflict. So, of course, to do this, we do have to transfer ownership to this struct. And this will give us an error saying, your classic borrow after move error. So, okay, let's just make this a reference then. We won't take ownership. We'll just pass it in and see what happens. Of course, this will also generate an error. This one is relatively more straightforward. Name is the wrong type. So it wanted a string. It found a string reference. So, hey, try this. Sure. Okay, Rust compiler is smarter than us. So we'll try this. And this actually works. This compiles, this runs. But once again, if you add the sort of print statement here, you'll get William Eustis. You won't get William Eustis as cool. And this is because the toString method actually does clone it. So it's sort of sneakily in the back end. We can open up the documentation, and we know it clones it. I won't read the entire toString method. It's sort of hard to read and uses this sort of formatter instead of other ways. But in either case, this is just kind of cloning this string and creating a different copy. So, we aren't breaking the laws of ownership here. But, okay, this does sort of raise the question, how would we do this, right? If we want this struct to point to some string that exists, or any data object that exists on the heap that we want to be able to change in other locations, Well, okay, one option is just to pass a mutable reference from the struct into something else, but maybe more concisely, if we want to retain ownership in some other location, and then have the struct be the thing that is referencing it. How is this possible? Well, okay, it is possible, is what I'll caveat this by. You can do this. However, you have to tell the compiler the lifetime of the data. Because this issue of, if the student struct does have a reference to name, and something else owns name, some little block of memory called name, I'll just say X owns this. If X goes out of scope and is dropped before the instantiation of this student class does, then this memory is no longer valid, and we still have a reference to it. We still have a reference to it. And then our computer explodes and catches on fire, which is bad. And so there is a way to do this. We just have to define the lifetime of the data. We may or may not cover this. Lifetimes in Rust can be a little annoying to work with. You might, at one point in your life, get a compiler error telling you about them. If you are, I encourage you to learn about them. If we do cover this, this is going to be in the last couple lectures, in the last couple of weeks during final projects. So if there's some interest for us to cover this, just let us know. But okay, this is a relatively uncommon situation, but it's uncommon that there's not another option, I guess, is the true thing. And that other option is just have the struct own it and pass references from the struct to other things that need to maybe adjust it. Okay, and then our last little topic here is some special structs, what we call a tuple struct, which is a little bit like a tuple and a little bit like a struct. Sometimes with these more simple structs or simple data types, it's sort of annoying to name every single different field, and then to instantiate it and name every single different field. But accessing it is nice because we sort of know what this thing actually is. But maybe there's not really a great meaning to this thing, right? In this example, which is based off of MP1, which you can't read because that's on a blue background. In this example, each of these values obviously represent some information about a food. But, if they just represent some arbitrary data points, there's no reason to name them, 0, 1, 2, 3 or something, right? So we can use what's called a tuple struct. And a tuple struct is basically, you can just think of it as a named tuple. We define our tuple struct to have 4 float32s. Most importantly, we just sort of don't name the fields. When we instantiate it, we just pass in the values. Again, we don't have to worry about the names of the fields. And then when it comes to indexing into it, we can use our tuple indexing .1, .0, whatever. And that's it. So thank you so much. Hopefully y'all enjoyed this. Good luck on MP1, and come to office hours if you ever need help. See ya.